Well, it feels today that we've got to a point where we've actually proven the concept. There has been a lot of work carried out in modifying different aspects. The laser and the thermal camera, we did a lot of work on other concepts to be able to put different heat methods into the materials, and there has been a massive amount of work carried out on the software aspects of this particular application as well. Notwithstanding that, there are also the miniaturization and automation. This also has proven difficult, but I think we've overcome these problems.
Well, it feels really good. I'm happy with the presentation and the demonstration and all the questions we got from the audience, so I feel relieved.
Well, today I feel really satisfied with the result we had. We have just proof that our system is capable of detecting real cracks in a real scenario, in a relevant environment, so I feel really satisfied.
Inspection of welds is today quite often a wet and time-consuming process. With the method presented here, that will be history, and it will be possible to inspect areas with limited access, which may be impossible today. The team, consisting of people from IK4 Lortec, Technitest and GKN Aerospace and University West, located in Spain and Sweden, has been working for about 2.5 years with developing the method. There are still some work left before there is a product ready for commercial use, but the result looks really promising.
So far we have shown the proof of concept, but further development is needed, a bit more research before we can see it in production.
So how much is it left to do you think?
A couple of years, I should say.
The cost of this thing is not cheap, but the overall project, should it come to fruition, should it be complete, will save a vast amount of money because of time, and because it's automated, will save money in personnel time as well.
Is it a reliable method?
That's a question we need to answer within the forthcoming research project.
It will certainly have an impact in the aerospace industry, and not only just the aerospace industry, but also in the motor industry and possibly the oil and gas industry, where there are remote areas where you cannot inspect. Nuclear industry as well, where you cannot inspect in these particular areas. We need to be able to inspect remotely, and this is where this particular technology will come in.
Well, the impact of this system is, I would say, is quite large, as welding is a really important process and quite complex. Actually, it's not really well understood, and the inspection of welds is crucial not only in the aerospace industry but also in some others.
With this method you can detect surface cracks in the order of 30 microns here on Inconel, but research is already ongoing with other crack sizes and materials.
We have evaluated different methods over the time, and we found that for this particular application, thermography with laser-induced heat is the best for this method.
Will it make a difference?
We hope that it will make a difference. It will make the whole process of inspecting in these remote areas, specifically in the stator, and there will be lots of other applications where this particular method can be used, providing we carry out certain modifications.
How big is this? Will it have an impact?
I think it will have an impact, and I hope it will have an impact. For sure it will take some time before we reach that impact, but it looks promising.